Hello everyone, today I'll show you how to add this UI material that will allow you to make this parallax effect on your heads-up display. As you can see, the UI is moving with a delay from the movement of your character. This effect originally was done by Uriah. He's very helpful, he has a Discord channel. I'll leave links to his YouTube channel and the Discord channel so you can follow him and stay updated with his developments. He's very helpful and answers all the questions that you have. Okay, let's start with the tutorial. You can see in this demo file that when I move the camera, the UI is following with a delay and it's resting in the center of the screen when you stop moving. This is due to this parallax effect that we're creating now. But you can use this method to create any material-based effect to your UI. You'll see later where you can add any material to add any additional effect to your UI. For example, in the video you saw prior to this, you can see that this pixelated effect on the text and the graphics on the UI, it's just additional effect. So this method is used for a lot more than this parallax effect. But let's continue with the material for this effect. I'll briefly show you how it's working and then we'll recreate everything. First, you need to have your heads-up display widget. Inside, you have a canvas panel with a retainer box inside. This is the important part. In this retainer box, you can add an effect material. This is what we'll use to drive the parallax effect and have any additional visual effects added to your UI. You can see that this retainer box is bigger than the actual screen, which is represented by this canvas panel. This is done to allow the movement of your camera inside, not to cut out the ends of your screen. In the demo, you saw that there is a little vignette on the outside. If you didn't have this retainer box bigger than the screen, when the parallax effect is applying, you will see the end of this black border outside. So this is the reason that you have this bigger than the screen. And inside you just have the size box and another canvas panel with currently just this border to represent visually the UI. Otherwise you will build your whole UI inside this canvas panel here. The material used in the retainer box is what drives the parallax effect. You can see that everything is being driven by this material parameter collection parameters with a little bit of math based on your screen size and some other parameters. It's moving the UVs for the rendered image of your UI, and everything here, the values for the parameters, are actually being updated in your character blueprint. It looks a little scary at first, but it's actually, when you understand what it's doing, it's quite simple to follow. Now let's start recreating everything so you can see how it's done and understand how it's working. First, I'll start with the creation of the heads-up display UI. I'll delete the current files, and now you can see that we are starting with just the default first-person template. Now what we'll do is create blueprint class. You can choose the type, this heads-up display class is fine. Call it blueprint heads-up display, and now create the widget that will be our heads-up display and call it widget heads-up display. Inside this widget, I'll add for now a canvas panel and a border just to see if it's working. Inside the heads up display class, go to the event graph, and on the begin play event, let's create widget, choose our widget heads up display class, and let's add to viewport, connect the return widget here to the target. Now when you go to your game mode, for this example map it's this first person game mode, just set your heads up display class to the blueprint that we created, and if you play the game you will now see the UI, which is currently just this white box, is applied to our screen. Okay, let's actually make our UI here, delete this box, and now let's add the retainer box. It's found in the optimization tab. Drag it onto your canvas panel and then set the anchors to the full screen and all the offsets to -64 in order to have this buffer outside of the screen. Then put a size box inside, and inside the size box put the next canvas panel with a padding of 64, which will now be the size of your screen. Inside this canvas panel I'll put the border that we have as an example earlier. Again, put all the anchors to the 4 corners, change the offset to 64. Here into the appearance, change the draw as to the rounded box. Outline will be vibrant green color with an alpha of 0.5. The width of the border will be 2. And here the tint will just change the alpha to 0, and that way we only have the outline like in the example you saw before. This is everything we need for the example heads up display. I'll close it, hit play, and you will see that we have the heads up display in our screen. Now only we need to change the material in order to have the movement. And we'll start with the material parameter collection. Create material parameter collection, call it MPC Parallax, and inside you'll need only one vector parameter. It will be called parallax offset, and the default value will be 0 for everything. This is all we need into our material parameter collection. Okay, let's create our actual material to drive the parallax effect. Right click, materials, and then material, call it m_parallax, and inside this material change the material type to user interface and change the blend mode to alpha composite to use the opacity value. Now create texture sample parameter 2D and call it slate UI. We'll use this parameter to represent our UI on the screen, connect the color to the final color and the alpha to the opacity value. Now click save, and let's go back to our heads up display to set up this material to be used, and then I'll show you how it works. Let's go back to the heads up display widget, click on the retainer box. In the effects panel here, choose m_parallax, and into the texture parameter put the same name that you called your texture parameter into the material, slate UI. Click save, and then if we hit play, you can see that we have no change. But if we go to our material, let's create texture coordinate, then multiply that by 2 and connect it to the UV. Click Save, and now you can see that our UI is multiplied 2 times in the X and the Y axis. This was just an example, we don't want to do that. Let's use an add node. It's another example. Hold 2 and click here for creating a 2 vector. Connect it and put the values 0.5 and 0.5. This will move our original heads-up display 0.5, so 50% to the left and 50% to the top. It is currently repeating itself over and over, so let's choose here the texture parameter value and the sampler source. Let's change that to shared QAMP. Click Save, and now you can see that we are no longer repeating our UI. We are just currently moving it 50% to the left and 50% to the top. If I put 0, 0, it will go back to the middle. The important thing here is to remember that whatever values you add to the texture coordinate, they are moving the heads-up display, the first value from left to right and the second value from bottom to top, and the values are going from 0 to 1. If you go over 1, you're going to be outside of the screen, so we don't want to have any values above 1. Okay, let's delete these example values and let's create our actual values here. Drag in the material parameter collection that we made earlier. Change the parameter name here to the parallax offset. This is our only value. Break the vector. We'll only use the first 2 components currently for the X and the Y values, so break out float 2 components. This will use the R and the G. These are the first 2 values from our material parameter collection vector. We'll use the screen resolution function in order to drive our movement of our UI based on the size of the screen. So break the same vector, the visible resolution vector, the same way that we did for our parameter collection. We'll have the same 2 values for our parameters and for the screen resolution parameters. And this screen resolution is returning very high values. For example, for full HD screen, this will be 1900 by 1000 roughly. So we need to multiply these values by a very small number in order to get our values between 0 and 1 that we need for this coordinate movement here that I demonstrated earlier. So let's create 2 parameters. Just hold the 1 key and click somewhere to create just a value and convert it to a parameter. We'll call that parallax offset degrees to screen X. Let's hold 1, click here, convert to parameter, and have the same parameter with Y. This for our X coordinate and this for our Y coordinate. And we need to multiply these values by the X and Y coordinates returned for our resolution. So have it like this, and put the default values for X and Y as a very small number, because we need to convert the huge number for our resolution into some very small number to fit our values between 0 and 1 here. So a good value here will be 0.50, then 1 for the X coordinate. And for the Y coordinate, we also need to flip the direction, so we put a minus in front, and then 5 zeros and 3, because we roughly have 3 times smaller resolution by the Y side, by the vertical side. That's why we have a bigger number here. Then multiply the resulting values by the coordinates for X and Y in our parameter collection. The first one is for the X, and the second one is for the Y. Then append these two values, append vector, and add them here to our texture coordinates. This is basically the same setup as I showed you with the 2 vector before, that I manually put the numbers, but now our numbers are based on the resolution and also the parameters into our collection. So let's save this, and if we open our collection and we change these parameter values, let's put, for example, 5 here, you can see that it is moving our UI. Let's put 10, 100, 500. 500 is too much. But you can see that the values for the R and the G are moving our UI up and down and left and right. Let's set back the default values to 0. This was just an example how it's going to work to move our UI. Set them to 0, click save. And now that we know our material is working, we are done with everything for the material setup here. And we'll continue with our actual player blueprint based on our movement of the camera to set up these material parameter collection values to drive the parallax effect for our camera. Let's continue with that. Go to our character blueprint, open the event graph, and we need to set up our process into the event tick. This will update every frame the position of our UI parallax offset. We'll need a couple variables to start here. Let's go to the variables panel, click on the plus sign, and start creating our variables. We'll start with the yaw rate. It will be of a type float. Then pitch rate. It will again be a float type. Let's have a min max yaw rate and min max pitch rate. Let's set these variables compile and save in order to be able to set up the default values. Yaw rate and pitch rate will have default value of 0, and min max yaw rate will have default value of 5, and min max pitch rate will have default value of 5 as well. Compile and save. We'll also need one variable for our camera rotator, and it will be of a type rotator. And let's start our setup. Drag the first person camera into the event graph and get world rotation. From our camera rotation, we'll break the rotator and use the pitch and yaw values to set up our pitch and yaw rates. Let's start with the pitch rate. We'll subtract from the camera pitch rate our current camera rotator pitch rate. So control drag our camera rotator, then split the pin and subtract our pitch value from the pitch value of the camera. Then we'll add our current pitch rate. Control drag the pitch rate variable here and add it to the result of this calculation. Then the result will clump the float value between the values for our min-max pitch rate. So control drag our min-max pitch rate here. set this value for the max. So as you remember, our value here is 5, and for the minimum we'll use the -5. So multiply by -1 and we'll get -5 for the minimum, 5 for the maximum, and this will be the value that we need to set as our pitch rate. So out drag our pitch rate here and set it to this value. We'll need to do the same for our yaw value. Let's do it down here. Subtract from our camera yaw our camera rotator yaw value. Let's move this down. And now add our current yaw rate to the result and then clump the value with the minimum and maximum yaw rate. We'll use this for the maximum and multiply by -1 for the minimum in order to have the value between -5 and 5. And we'll set this value to the yaw rate. Then we'll set our camera rotator to this world rotator. Okay, now we have our values set up. Now we need to interpolate between the current value and the desired value for the position of the parallax offset. We'll set these values into two variables as well. So create a new variable, call it pitch parallax offset. It will be of type float, and one additional that will be yaw parallax offset. And let's set them now. What we'll do for our parallax offset values is take the current pitch parallax offset, then we'll interpolate. So start typing interpolate and choose this interpolate function. We'll interpolate our current parallax offset to the desired pitch rate that we calculated here. And for the delta time, we'll get world delta seconds function. And the interpolation speed we'll set to 5 for now. You can use a variable, but just to be more readable now, let's have it like this. So this will be our pitch parallax offset. We'll have the same for our yaw parallax offset, but we'll have the current yaw value and the desired yaw value plugged in here. The delta time will again be the world delta seconds, and the interpolate speed will be again 5. We use those values to set up in our set vector parameter value in our material parameter collection parallax. Parameter name will be parallax offset. Let's split this pin and connect these values. The yaw value will be the first one and the pitch value will be the second one. Compile and save. And if we go back to our viewport and hit play, you'll see now that we have a parallax effect on our screen. When I move down, my heads-up display moves to the top of the screen, and when I move left and right, it moves to the end of the screen horizontally. Now, the only difference from our example before is that it doesn't center after we stop the movement, so we need to do that after we set the parameters here. So after we set the movement of the UI with this vector parameter, we'll interpolate back our pitch rate and our yaw rate to 0. We use the same interpolation here. We'll use the current pitch rate. We'll interpolate it to 0. We'll use the same delta seconds here and the same interpolation speed 5 for the pitch and the yaw rate. Get the current yaw rate here. Target again will be 0 and the delta time will be the world delta seconds. Compile and save. And now if I go back and hit play, you'll see that I have the parallax effect, and if I stop moving, the UI is going back to the center of the screen. This is exactly as our example before. If you want to modify the values, you can have a bigger minimum and maximum. For example, I can have 10 for the yaw and the pitch rate here. If I compile and save, click 5, you'll see that I have a much bigger movement for my parallax effect. Let's set them back to 5. And if I want to have a faster speed, you need to change this interpolation speed. Let's make a variable for this in order to have it changed just on one place. So promote this to a variable. It will be the interpolation speed variable. And let's connect it to all 4 interpolation functions. Compile and save. And for the default of the value, let's change now to 100, for example. And if we go and hit play, you'll see that it's very, very fast. It doesn't look really good. So stick to the smaller values. If I put 1, compile and save, it will be slower. It doesn't really have the time to go to the maximum and the minimum now. The value of 5 seems fine. It depends on your preferences, but I think that this is a good value. And this is everything you need to recreate this parallax effect. As I said, you can have additional effects like this pixelation effect, like the curved display that he has here. You can see that the UI is curved based on the position on the screen. You can add any additional effects to your material, and they will apply from your retainer box material effect to your viewport's heads-up display. And that's everything for this example. Please, if you have any questions, let me know. You can subscribe for the channel. You can like this video if you like this tutorial. And if you have ideas for new tutorials, please let me know in the comments, and I'll be sure to try to make the next one sooner. Thank you for watching, and again, please like and subscribe, it will help a lot, and see you in the next video.